Hi everybody, today we are getting on to chapter 3, which is exponential functions, and today we're going to start with section 3.2. So we're going to cover 3.2, 3.3, and then we'll go back to 3.1 and 3.4 and 3.5. Okay, so we're going to start off with something we looked at last year, which are the exponent laws. Okay, so just recall that a is called a base, x is an exponent, and a to the x is referred to as a power. However, we do use exponents and powers interchangeably, so that's okay. Okay, so the first exponent law is when you multiply like bases, okay, you can write it as a single power by adding the exponent. So it's a to the exponent x plus y. Okay, when you're dividing like bases, you subtract the exponents, so that is a to the x minus y. And when you have a power of a power, you multiply the exponents, and that becomes a to the x times y. Okay, so simplify the following. All right, so we have, this is called the monomial, and a monomial. Okay, so you're multiplying, you multiply the numbers, which are also called coefficients. So we get 2 times 3, which is 6. And then we multiply the x squared and x to the fourth. And because you're multiplying, you add the exponents. That simplifies to x to the 6. Okay, next one, we're multiplying 3 like bases. Okay, and notice that the a in the middle does not have an exponent written. So whenever it doesn't, it is a 1. We just don't write it. So again, we're multiplying, so we add the exponent, so we get 2 plus 1 is 3 plus 3 is 6. So we have a to the 6. Okay, and the last one, okay, so we have 3x squared y to the exponent 3. Now this exponent 3 affects each term within the brackets, so it's going to be 3 to the 3, x to the 6, right? You multiply, and then y to the 3. And then we evaluate the 3 to the 3, third power of 3, which is 27, x to the 6, y to the 3. Okay, next one. Now we're dividing, same thing, you divide the coefficients. So you divide 12 and 4, which is 3. So if the 4 didn't divide into 12, suppose that, for example, it was like 8, then you would just reduce the fraction. Okay, but in this case, the 4 divides in, so it becomes 3. X squared divided by x, you subtract the exponents, so it's just x, and then y, because there's no y in the denominator. Okay, and last one, a review. So this one here, we have sort of power of power, so we're going to do it in a couple steps. So the first one is, we're going to have 2 to the power 2, which is 4, x squared, y to the 4. And then we're going to have 2 cubed, which is 8, x to the 6, y to the 3. Okay, and then we're going to multiply, and we're going to get 32, x to the 8, y to the 7. Okay, good. So that was a review of grade 10. Okay, and now we're going to get on to what we're doing this year, which is we're working with negative exponents and also with the power 0. Okay, so I said evaluate the following using your calculator. So you're just going to plug this into your calculator. You plug in 2, use your exponent button, then -1, and you should get a 0.5. Okay, if you plug in 2 to the -2, you're going to get 0.25. And if you plug in 1/3, make sure it's in brackets. You do bracket 1 divided by 3, close bracket, to the -2, and you should get 9. All right, so now we're going to see how your calculator came up with those numbers and what it means to be a negative power. Okay, so the way that we learn about the 0 power, okay, and negative powers is we just follow a pattern. Okay, so we're going to evaluate each of these. So 2 to the 4, okay, again means 2 times 2 times 2 times 2, which is 16. 2 to the 3 is 8. 2 to the 2 is 4. And 2 to the 1 is 2. So we know those so far. Okay, that's going back to elementary school. Now we're going to continue the pattern. So have a look at the exponents, and we're going from 4, 3, 2, 1, 0. Now. So we're going down by 1 each time. And notice that every time we go down by 1, the number gets cut in half. So through the logic, right, we're going to continue cutting the number in half. So if we cut 2 in half, that becomes 1. We cut 1 in half, that becomes 1 over 2. We cut that in half, that's 1 over 4. We cut that in half, that is 1 over 8. All right, so I said, what do you notice about negative exponents? So essentially, it's very similar to its positive counterpart. So for example, 2 to the 2 is 4, 2 to the negative 2 is 1 over 4. 2 to the 1 is 2, 2 to the negative 1 is 1 over 2. 2 to the 3 is 8, 2 to the negative 3 is 1 over 8. So essentially, a negative exponent just means the reciprocal. Okay, so I said in general, a equals negative 8, the negative n is equal to 1 over a to the positive n. Okay, and similarly, 1 over 8 the negative n is equal to a to the positive n over 1, or just simply a to the positive n. All right, so now, according to the rules of math, a simplified answer does not contain negative powers. If a negative power is in the numerator, then we say switch or move it to the denominator. And if a negative power is in the denominator, then switch it to the numerator and make it positive. All right. Oh. Put that back. Beautiful. All right, so example, write each power with a positive exponent, or write each as a positive power, whatever you want to say. So this right here is we have 4 to the negative 2, so we're going to put that in the denominator, so it's going to become 1 over 4 to the positive 2. And I didn't say evaluate, I just want to rewrite it like that. Okay, next one here, 2x to the negative 3 is going to be 2 over x to the positive 3. Okay, notice how the 2 is not affected by the negative 3. If it was in brackets, then it would be. Okay, this one right here is going to be 1 over xy to the 2. And then this one is going to be, okay, this is a tricky one here because there's a negative up front. That means negative 1 times that. So it's going to be a negative in the numerator, and we're going to have an x squared. Okay, the negative is usually written beside the sort of the division line. Okay, so this one's a little bit different now because now I'm saying evaluate. So we're going to apply the exponent rules first, then we're going to evaluate. Okay, so here we're going to have 3 to the negative 2 to the negative 1. That's a power of a power, so we multiply exponents. So we're going to get 3 to the positive 2. And then evaluate means figure that out. So 3 times 3 is 9. Okay, next one here. We're dividing, so we're going to subtract exponents. Just remember, there's a 1 there. So we have that 5 to the 1 divided by 5 to the negative 2. We're going to subtract exponents. Remember, 2 negatives make a positive, and that's equal to 5 to the 3, which is 125. Good. And the last one. Okay, we got a couple things going on here. So we're going to write it as a single power, which is 3, and we're going to do 3. We're going to 3 plus the negative 2, and then minus 4. That's equal to 3 to the negative 3, which is 1 over 3 to the positive 3, which is 1 over 27. All right. Okay, now the last type, we're going to simplify the expressions, and remember, when you simplify, the answers need to have only positive exponents. Okay, so we'll do the first one here. Okay, so we're going to follow the same rules that we did in grade 10. Okay, you're going to multiply the coefficients, which give you 6. And you have x to the negative 2 times x to the negative 4. You're going to add those, so you're going to get x to the negative 6. Okay, so now we simplify, and the 6 stays in the numerator, and the x to the negative 6 becomes in the denominator, and the exponent becomes positive. So this is the simplified answer. Okay, next one. Okay, we're going to take it in steps. We're going to apply the negative 1 to each term on the inside. So we're going to have 4 to the negative 1, x to the positive 2. And that becomes x to the 2 stays in the numerator because it's positive, and the negative power goes to the denominator, and that's 4 to the 1, which is just 4. Okay, good. Okay, next one, we're going to apply the 2 to each thing again. So we have 2 to the 2, x to the negative 2, y to the 4. Okay, and now the only thing that's going to go into the denominator is the x, and then we're going to always evaluate, never leave it as a power. So 2 to the 2 is 4, y to the 4 over x squared. All right. Okay, next one, and there's different ways to do these. You can just sort of flip that, make that positive, right? But I prefer to just apply the exponent to each term on the inside first, right? So we're going to write this one here. It's going to take up a little bit of room. So we're going to have 4 to the negative 2, a to the negative 4, over 3 to the negative 2, b to the negative 2. Okay, and now we notice here that everything's negative, so everything's got to be switched. So it's going to become 3 to the 2, b to the 2, over 4 to the 2, a to the 4. And now we evaluate. So 3 to the 2 is 9, b squared, over 16, a to the 4. Okay, good. And last one for today. Okay, again, we're going to apply it. So we have a to the 6 over 3 to the negative 3, y to the negative 6. And the a to the 6 is going to stay in the numerator because it's a positive power. And then these two are going to come up. So we're going to have 3 to the 3, a to the 6, y to the 6. And then we evaluate. So we're going to have 27, a to the 6, y to the 6. Okay, and there's your work for today. That's it.